Hello and welcome to the MecSoft demonstration series, where you can see live demonstrations for real users and real-world applications. For more information about our products or to schedule your own live demonstration, just give us a call or visit us at www.mecsoft.com. Without further delay, we invite you to sit back and enjoy the demonstration.
So the next thing we wanted to cover is feed rate optimization. And in your 2.5 axis machining, here are some of the things that you want to keep in mind. You probably want to optimize your feed rate when plunging between cut levels, and also during the first XY pass, when the full width of the tool is going to engage with the material. And those are a couple of examples where you might want to optimize the feed rate. And a third one is at sharp corners, and where you might want to decelerate and accelerate as you're approaching sharp corners. And we will go ahead and demonstrate this as well. So again, this is all about feed rate optimization in your 2.5 axis machining.
Thanks, Krish. So folks, we'll now talk about how we can optimize feed rates in 2.5 axis operations. Now this can be done in 2.5 axis operations as well as operations that are programmed using Z levels. It could be even like a roughing operation, 3-axis horizontal roughing. Now to cover this, I'm going to take a simple example in here where we have a couple of different operation types. The first thing we want to talk about is the feed rate optimization, where we have the ability to reduce the feed rate when using the first XY pass. Now you can specify your feed rate optimization, feed rate reduction parameters under the feeds and speeds tab, and you have the ability to set this for the first XY pass. So I've set it to use 10% of the cut feed rate. So it will basically use 10% of the cut feed for the first XY pass. Now as you program a toolpath, in this case I have a pocket operation programmed in here, and you will notice that as you check your toolpath viewer, you'll notice that on the first pass the feed rate is reduced. It applies the feed rate cut factor. So as you post-process the toolpath as well, you will notice that the feed rate drops down to 10% of your cut feed rate when it's performing the first XY pass. Your cut feed rate is established as 40 inches per minute. So the first XY pass will reduce it down by the specified reduction factor. In this case I chose 10%, so that would be 10% of the cut feed rate. Now this can be applied in your 2.5 axis operations, like pocketing as an example. You could also do it in facing and other operation types as well. So you can reduce the feed rate using the feed rate reduction parameters under the feeds and speeds tab. Now we can also use feed rate reduction when we plunge between levels. So in this particular example here, I'm cutting a profile on the exterior of the part, and I'm not applying entry and exit for each of the cut levels. So as the cutter plunges from the first level down to the next level, you could apply a feed rate reduction factor. And again, I've specified to use a 10% of the cut feed rate for the plunge between levels. So for each of those cut levels, as you plunge between levels, you could reduce the feed rate. And you'll notice that as you take a look at the toolpath viewer, you'll notice that as it plunges between the levels, it reduces the feed rate. So when you post-process your toolpath as well, you will see that the feed rate is being reduced as you plunge between levels. You'll notice that the feed rate drops to a feed rate of 10% of your actual cut feed rate. So it drops to 10%, which is feed rate of 4 inches per minute in this particular example. Now these options are available to you in all the configurations of our CAM product, the feed rate reduction for the first XY pass and also plunge between levels. Now to reduce feed rate around sharp corners,
Uday, hang on 1 second. I just wanted to break in here. And regarding the plunge, one of the things you might want to explain is if the user is cutting a really hard material and he really doesn't want to plunge, there's an option where you can apply the entry exits for each level. It'd be nice to show that.
Sure, we'll do that, Joe. Thank you. So rather than applying a plunge between levels, you could choose to apply entry and exit for each of the cut levels, and then generating a toolpath will result in the plunge, approach, engage, cut, and retract motions for each of the cut levels rather than just doing a Z plunge as you cut from one Z level down to the next level. If you're not applying entry and exit, that's when you can take advantage of the feed rate reduction factor for plunging between Z levels if needed. Now the next feed rate reduction parameter we're going to talk about is how to reduce feed rate around sharp corners. So in this particular example here, you'll notice that the inside corners here are sharp corners. So to reduce the feed rates as you change direction, as you approach the sharp corners, you could use the toolpath editor, which is available in our Pro configuration. So once you have a toolpath programmed in here, you could go into the toolpath editor and select feed rate optimization, and you can specify the parameters. So the distance before the corner to start reduction and after the corner to reset the feed rate back to the original cut feed rate. You can also specify the minimum distance between the feed rate changes and also the percentage by how much you want to reduce the feed rate by, and you can specify all of these parameters, and as you apply it, you will notice that as you get to these corners in here, the feed rates are being reduced. So you'll see that information being automatically updated in the toolpath editor. So it's basically before it gets to half an inch before the corner, it's going to drop the feed rate down by 10%. And then once you go past the corner, it'll restore the feed rate back to its cut feed rate that you programmed in here. And this can be applied to all the corners in here that you program. So in this particular case, I'm demonstrating this on a profiling operation. This could be done on facing, pocketing, and profiling operations, or pretty much any operation that involves XY cut patterns in Z levels, multiple Z levels. So you'll notice that the feed rate is being reduced before the sharp corners. So this functionality, feed rate reduction around corners, is available in our Pro and Premium configurations, which are part of the toolpath editor.